here we go for section 4.5. This is on isosceles triangles. So an isosceles triangle is a triangle with two congruent sides. The base angles of an isosceles triangle are also congruent to each other. And an altitude or height of a triangle drawn from the shorter base that splits an isosceles triangle into two congruent right triangles. And I also want to go over some different parts of the isosceles triangle because I think that will be helpful to you. So first thing is that we just said an isosceles triangle has two congruent sides. Here's the two congruent sides. The side that is not congruent, one of the congruent sides is the base. Okay, so I'm going to label this as the base. And up here, I would like you to write this on your notes as well, is that the base in this particular picture is AC. The base does not necessarily mean the bottom of the triangle, okay? It just means it's the side that's not one of the congruent sides. All right, so just keep in mind, the figure could be turned, and the base could be up here or here, depending on where the two congruent sides are. All right, the legs are the two congruent sides. So in this case, this is a leg, and this is a leg. Those don't look like G's. So I'm going to say that the legs are AB and BC. Okay? Then the next thing is the base angles. I mentioned here the base angles of an isosceles triangle are also congruent. So if these two sides are congruent, then the angles opposite those sides must be congruent also. And those are the base angles, or you can also see, well, if this is the base, then the base angles are the two angles that make up part of that base. So base angles are angle A and angle C. All right, and then the last thing I want to mention, that third angle is called the vertex angle. And that, in this case, is angle B. Okay, so you just want to be careful with that. And again, keep in mind that even if I drew the triangle like this and said, okay, well, these are the two congruent sides, then that would be your base. And these would be your legs. Okay, or if I drew the triangle like this, then these would be your legs, and this would be your base. Okay, so again, base doesn't necessarily mean bottom. It is referring to the side that is not one of the congruent sides. All right, for an isosceles triangle theorem, it's giving you some information here. If two sides of a triangle are congruent, then those angles opposite those sides are congruent. So they're telling me if AC is congruent to BC, then I therefore know that these two angles must be congruent to each other. Okay, so the angles opposite the congruent sides must be congruent. Those are those base angles. All right, so let's go and get that moved up. And now we can look at theorem 4.4. So theorem 4.4 is the converse of the isosceles triangle theorem. What it says is that if two angles of a triangle are congruent, then the sides opposite those angles are congruent. So it's just, the backwards version of what we just talked about. If I see two angles congruent, then I therefore know the sides opposite those two angles must be congruent. Okay. Example 1 says, is AB congruent to CB? Okay, so they're wanting me to say, is this piece from here to here congruent to this piece from here to here? And again, I just can't guess. I have to know for sure. So if I think about the information, or look at the picture, then I can see that this angle is congruent to this angle. Okay, so the sides across from those angles must be congruent to each other. So yes, this side must be congruent to that side. Okay, so I know the answer to that is yes. Okay, it didn't say to give a reason, but it's a good habit to get into. Yes, since angle A is congruent to angle C. Okay, Over here, it's asking me, switch colors here, is angle A congruent to DEA? So they're asking me, is this angle congruent to DEA, which is this angle? Well, now if I look at just this little triangle right here, I can see, oh, well, if these two sides are congruent, these angles opposite those sides must be congruent also. So if that has a 1 mark, that has a 1 mark. So I can say yes again. My reason would be since side AD is congruent to side DE. That would be our reason for that one. Okay? All right, so let's get that clear and move up and take a look at example 3. Okay, so if we look at example 3, it says find out what x is. So, you know, again, this is an isosceles triangle. These two sides are congruent, even though it kind of looks upside down from the one we talked about over there. I know that if these two sides are congruent, that these two angles must be congruent to each other. So if that one says 42, that one must be 42. Okay, the other thing that I know is that these two angles are congruent to each other. So if I can find out what this whole angle is, I know I can just half it to get what this one is. Well, if I look at just this big triangle, what do you know about all the angles of a triangle is you know they add up to 180. So I know that angle 42, the 42 plus the 42 plus this whole angle right here, which I'll call angle N, has to equal 180. Okay, so if I add these two up, I get 84. I'm going to call that measure of angle N, be more specific. And if I go and subtract 84 from each side, then I end up with 96. Okay, but think about what you're answering. That is giving me the fact that this whole angle is 96, but we just want to know what this piece is. So I therefore know that x is 96 divided by 2, since those angles are congruent. So I know that's going to give me 48 degrees for x. Okay, so just kind of think about what you're doing there. All right, the next little bit is talking about an equilateral triangle. An equilateral triangle is a triangle that has all 3 sides congruent, so that's what we're filling in there, and all 3 angles congruent. And each measure, if we think about it, if all these angles are congruent and we know all those angles add up to 180, then we know that 180 divided by 3 gives me 60. So each of those has to be 60, if you're going to write that in the picture. Okay? And that's kind of the main thing that it's talking about here. And we're going to use kind of a combination of these different things to solve some of these examples in example 4 and example 5. Okay? So if we go ahead and get that moved up. Okay. So on number 1, under example 4, I can see on some of these there is more than one way that you could do these problems. You also want to make sure that you could explain these if you were asked to explain them, like why you're doing what you're doing. I have on my notes that I posted in Canvas kind of the reason why I'm doing what I'm doing on all of these, if you want to look at that, but I'm going to kind of say it as we go through as well. Okay, so in this particular case, I know that if these two sides are congruent, I know that these two angles must be congruent to each other, okay, because it's an isosceles triangle. I also know that these are a linear pair, so I know that these have to add up to 180. So if I do, 180 minus 115, then I get 65. And I'll try and squeeze that in right there. Okay, so I know that if that angle is 65, I know that x has to be 65. And that helps me answer one part of the question. Okay, I also need to figure out what y is. So I'm going to try and put that that's 65. Now I see a triangle and I know all three angles must add up to 180 because that's the triangle angle sum theorem. So I know that I could do up here, I could say y plus 65 plus 65 equals 180, and I can solve for that. And when I solve, I end up with y is equal to 50. Okay? All right, on number 2, then, you know, I have to think, what kind of triangle is this? If all three sides are congruent, we just talked about it has to be an equilateral triangle. And we said if it's an equilateral triangle that's also equiangular, meaning all three angles are congruent, and they all have to be 60. So I know this angle 60, I know that angle 60, I know that angle 60. I don't want to say though that x is 60 and y is 60. I know that if this angle is 60 and this angle is 3y, I can say 3y equals 60. I know if this angle is 60 and this angle is also 2x, I can say 2x equals 60. And then I'm actually solving to figure out what x is and what y is. I can do that by, in this case, dividing by 3 on both sides. In this case, dividing by 2 on both sides. And so I end up with y is equal to 20. And in this case, I end up with x equals 30. Okay, that's not the whole angle, so I'm not putting like a number of degrees in there. That's just what x and y is equal to. Okay. If we look down here at number 3, then again, I see a linear pair. I know those two angles have to add up to 180. So I know that I can go x plus 110 is equal to 180. And I can solve and get x is equal to 70. And that is a whole angle, so I'm going to put degrees there. Okay? Again, when I find something, I think it's very helpful to put it in the picture if I can fit it in there, because I think putting it in the picture helps you see what to do next. Now, if I look at the picture now, I see that I'm just dealing with this little triangle right here. I don't even need to pay attention to this triangle. If I see a triangle and I know two angles and I want to find the third angle, I can use the triangle angle sum theorem, the fact that all the angles add up to 180. So I can say y plus 70 plus 90 equals 180. And if I solve for that, I can solve and get y is equal to 20. Okay. All right, on number 4, then in this case, I can tell that if this is an isosceles triangle on this side, then I know that these two angles must be congruent to each other. Okay. And if I already know that this is 90 and all these have to add up to 180, then one way you can think about it is that's y, that has to be y also if they're congruent. So you could write it as an equation y plus 90 is equal to 180. So I'd get 2y plus 90 equals 180, which gives me 2y is equal to 90. Which gives me y is equal to 45. Okay, and then really these two triangles are congruent to each other. You could think of it that way. You could also think of it as, you know, if all these sides are congruent and that's a right angle, then all of these have to be right angles as well. Okay. If we even go back to chapter 3, I know if these two lines are parallel and this is a transversal, then, you know, these two angles are same side interior angles, which must be supplementary, so they must add up to 180. So if I know that that's 90, and we just found out that this angle is 45, then I know x has to be 90 minus 45, which is 45. Okay? So that takes care of example 4. So let's go and get that cleared, and then we will do some more similar to that. Okay, so if we look at these, on example 5, it says find the measures of the indicated angle. So ACB, make sure you're finding the right angle, ACB, C is the middle letter, so it's talking about right here. And sometimes you might have to find something else first before you find the thing that it's actually asking for. So in this case, I know this is an isosceles triangle because these two sides are congruent. Therefore, I know that these two angles are congruent. So if that one's 45, that one's 45. And then I know that these two are a linear pair, which means they add up to 180. So I know that I can go 180 minus 45, which gives me 135. And so therefore I know on this case that the measure of angle ACB that they were asking for is 135 degrees. Okay, on number 6 it wants DBC, so if I find that, it is right here. So in this particular case, again, if these two sides are congruent, it's isosceles, which means these two angles must be congruent, and if that one's 70, that one's 70. Now I can see that if I look at just the right side of the picture, that it's a right triangle. I know two angles, I want to find the third, and I know they all add up to 180, so I can say 90 plus 70 plus measure of angle DBC has to be equal to 180. So if I add those up, I get 160. And if I go and subtract 160 from both sides, I get my 20. Okay, so that is for number 6. All right, on number 7, they want me to find out ABC, which is right here. I almost marked the wrong thing. Okay, so if I think about what's going on here, triangle down here on the bottom is isosceles. Two sides congruent. These two angles must be congruent. All right, if I want to figure out this third angle, I can add these up and subtract from 180 to get that. So I've got 55 plus 55 plus measure of angle DCE equals 180. If I add those up, I get 110. And so I know that measure of angle DCE is equal to 70. Okay, so that gives me that angle. All right, now if I think, oh, I see an X, and I know vertical angles are always congruent, so if that's 70, that's 70. I also know that this is an isosceles triangle because these two sides are marked congruent, so therefore these two angles must be congruent to each other. And so if this is 70 and these two are congruent, so they're both 55, and if this is 70 and these two are congruent, then they both must be 55 also. That's what makes sense. So I know that that's 55 and that's 55. So that's what it was asking for, is measure angle ABC, and it must be 55. Okay? All right, let's get that moved up. And a couple more on this page, and then we get 2 proofs, and then that'll be it for chapter 4, new stuff. All right, if we look at number 8, so on this one they want us to find out what angle M and N is, and I believe I started with figuring out what M was. So if I look at this triangle right here, first of all, sometimes the picture gets busy and that's what throws people off. So kind of focus on what you need to focus on. If these two sides are congruent, it's an isosceles triangle, which means these two angles are congruent to each other. So that's 45, this is 45, and we've already found out what M is without any work. Okay, now if we look at this triangle, the one that I didn't mark yet, I can see that, you know, right now I'm just thinking these two sides are congruent and it's just an isosceles triangle, but that would be telling me that these two angles are congruent. Okay. Well, if that's already 60, and I go 180 minus 60, I'm left with 120. And if these two angles add up to 120, and they're congruent, then that means they're each 60. Okay? Which really means that's an equilateral triangle. Okay? I really didn't really know it at first, but now I know it based on the angles. And then be really careful, it is asking for angle N right here, which is this little sliver. If I know this whole angle is 60, and I know this angle is 45, then to get what N is, I actually need to go 60 minus 45, which gives me 15. Okay, so just be careful for what it's actually asking for. Okay, then on number 9, right here, they didn't give us a whole lot of information, but we can still figure out all those missing pieces. Again, I see an isosceles triangle, so I know that if those two sides are congruent, these two angles are congruent. So if that's 68, that's 68. If I go and add those up and subtract from 180, I can get that angle. So I get 136. If I do 180 minus 136, then I end up with 44. Okay? Again, fill things in the picture as you go, and that'll help you find the next thing. So again, hopefully you're seeing the vertical angles here and here. So vertical angles must be congruent to each other. So I can say M is 44. And I can put that in my picture down here. And then I can see that if these are both in, then I know that they are congruent to each other. Okay? And I know that if this is 44 and these were both congruent, so they were both 68, and I know if this is 44 and these are both congruent, then they both must be 68, because remember, all the angles have to add up to 180 for a triangle, so I know that N is 68. And some people get a little confused, like, well, if two triangles are a different size, they can't have the same angles, but yes, they can. It's something we're going to talk more about in chapter 7. That means the triangles are similar to each other and not congruent. So similar triangles are the same shape, meaning the angles are the same, but not necessarily the same size. So they can have congruent corresponding angles, but just not congruent sides. And again, that would mean they're similar to each other. So that is an okay thing. All right, so let's get that cleared. And let's get this moved up. Let's see how long this is. Make sure I'm moving it up enough. Move it up just a little bit more. See if I can make that work. The black line gonna go away. Let me see if I can get it to go away from my computer. Okay, there we go. That'll help. Okay, so on example 6, 2 proofs, and then we're done. So triangle ABC is an isosceles with base CB. Okay, so again, if I want to label that as my base, I can. It also tells me AD bisects angle CAB, and that's something I told you we needed to be careful of in one of the other proofs. We're trying to prove that these two angles are congruent to each other. All right, so we've already got the given information in the proof. We don't have to write that. If we go and start with this first thing, it says triangle ABC is isosceles with base CB. Okay, so if I know that this is an isosceles triangle and I know that's the base, I therefore know that these two sides must be congruent to each other. So I can say that in my proof. I can say AC is congruent to AB. Okay, and my reason for that is going to be definition of isosceles triangle. Okay, because I knew what that word meant. And I knew that if that was the base, then I knew which two sides were congruent. Okay, from there, I can use this piece of information. Again, if it says AD bisects angle CAB, remember bisect means cuts in half, and it's telling me that AD is the knife cutting angle CAB in half. Okay, so if CAB is this big angle, and AD is the knife cutting that angle in half, then it's telling me that these two angles are congruent to each other. So I need to say that in my proof. I need to name with 3 letters because there's more than one angle at the spot. So angle CAD is congruent to angle BAD. And I can say definition of angle bisector because I knew what that word meant. Okay, Okay, in this case, again, it's an angle bisector because it's cutting an angle in half. Sometimes we're referring to a segment bisector because it's cutting a segment in half, but just be careful what it's saying. Okay, from there, I'm going to look at my picture and think, is there anything else I know is congruent besides what is marked? Oh yeah, they're sharing this side, so I need to put that in my proof. I can say AD is congruent to AD, and that is the reflexive property. Okay. From there, I can now say the two triangles are congruent. Now, this proof's a little different than the ones we were doing in 4.2 and 4.3, because I'm not trying to prove two triangles congruent. I'm trying to prove something else. This goes along with what we did in section 4.4 yesterday. So in those proofs, if you remember, we were still proving the two triangles congruent, just like we did in 4.2 and 4.3, but then we just did one more line after that to prove either a set of sides or a set of angles are congruent by that CPCTC. So I still want to say the two triangles are congruent. It's just they didn't give me that here, so I'm going to need to put the letters in the right order. Again, it doesn't matter how I name the first triangle. I chose to say ACD. But it does matter how I name the second one. So if I chose to go ACD, so I started the 2 mark angle, went across the 1 mark side, and then across the no mark side. I have to follow the same pattern over here. Started the 2 mark angle, across the 1 mark side, across the no mark side, so ABD. My reason, if I look at the markings on my picture, are side, angle, side, side, angle, side. There's 2 sides marked and 1 angle, and the angle is included or right in between the 2 congruent sides. And then now I can prove what I'm trying to prove. Once I say that the 2 triangles are congruent by one of my 4 reasons, then I can say any of those other 3 sets of corresponding pieces have to be congruent by CPCTC. And remember what we talked about, you can write the abbreviation, but every time you write the abbreviation, say in your head what it means. Corresponding parts are congruent, triangles are congruent. Okay, make sure you understand what that means. All right, one more proof, we can do it. Okay, so I'm gonna get that cleared. What I would recommend is trying the next proof on your own, and then check it with mine and get it fixed if needed. But they gave you a little bit of help similar to what stuff we've already done, but I think it would be good practice for you to do that. You may have this written as the assignment. I'm not positive that's what I'm assigning, so make sure you look on Canvas to get your assignment. And again, I would recommend practicing this proof on your own, and then you just pause the video, and then you can come back and kind of check to see that you did it right with mine. And let me again try to get rid of that black line so we can see the whole thing. Okay, so let me get the letter that you can't see up there, and that is an A. Hey, there's an A up there for Amazon. Okay, so if we look at our given information, it says triangle ABC is isosceles with base CB. So that's my base. D is the midpoint of CB. Okay, when we're trying to prove that these 2 angles are congruent to each other, again, we're still going to prove the 2 triangles congruent. I can already kind of see that's going to happen in line 5, and then we're going to do that one extra line. So if triangle ABC is isosceles, if this is the base, I know these are the 2 congruent sides, so I can say that AC is congruent to AB by definition of isosceles triangle. Okay. I also know D is the midpoint of CB. If D is the midpoint of CB, it means that D is right in the middle of C and B, meaning these 2 pieces are congruent to each other. I shouldn't be marking angles for midpoint, I should be marking side lengths. So I can say CD is congruent to BD by definition of midpoint, because I knew what that word midpoint meant. And then I want to look at the picture to think, is there anything else I know is congruent besides what is marked? Oh, yep, they share that side. Remember, that keeps showing up often and often. And so I've got AD is congruent to AD. All right, and that is the reflexive property. When I say same thing is congruent to same thing. Okay, now I can say the two triangles are congruent. And they actually already gave me the reason. They didn't even make you think of that. But again, when I write my congruent statement, the order of the letters matters. It doesn't matter how I name the first one. I chose to go A, C, D. Okay, so I went across the 1 mark side and then across the 2 mark side. I need to follow that same pattern over here. Across the 1 mark, across the 2 mark. So A, B, D. And they already gave me the reason is side, side, side. And now, again, once I say the two triangles are congruent, I can say any of those other 3 sets of corresponding parts must be congruent. In this case, they want me to say that. And my reason is going to be CPCTC. All right, and that is it for section 4.5. Again, if you have any questions, feel free to message me on Canvas and let me know.